Okay, let's talk about some components of various assorted pulleys and snatch blocks and blocks. First off, what is the difference between a pulley and a snatch block? Well, a pulley is any device that has a sheave in it. This is a single sheave pulley. This is a double sheave pulley because it has two sheaves in it, or two pulleys. Theoretically, pulley and sheave are interchangeable, but not exactly. This is a single sheave pulley. This is a large single sheave pulley. But generally, multiple sheave pulleys are called blocks. This is a two-sheave block. This is a three-sheave block. A block and tackle is a combination of two or more blocks that are rigged for the purpose of mechanical advantage. So tackle is the addition of the rope and any other hardware necessary in conjunction with your blocks, and that becomes a collective term, block and tackle. So these are blocks. Generally, the term snatch block comes from a type of a single sheave pulley that is used basically for the purpose of changing direction only. This is a cable snatch block, and it's designed to where I can unscrew this pin insert a cable over the sheave and close the side of the pulley back, and now I can hook this into a device with the cable coming in one direction and leaving in another, or coming in one direction and going straight back in the same direction that it came in. But it is basically to change direction. But there is a way to rig the changes of direction so that you get mechanical advantage without having two and three sheave pulleys involved. And that's going to come in the rigging aspect of what we do in a little while. That'll come in part 2. Now, you must understand the terminology of components of these devices. It's just like knowing the components to the hydraulic rescue system, the components of a land search, the components of any other phase of rescue is very similar to knowing the name of the components of the devices here that you're using. Now, I will talk about this first, and then I'll focus up on it a little bit closer so you can see. This is called the hook. All three of these have hooks. These do not. The hook. Notice that on this hook there is no safety to prevent whatever is in the swallow of this hook from coming out. Notice that on this hook there is a mechanical safety device such that whatever you hook this hook over does not come back out. This is an extra added safety, but not all blocks have the safety hooks. Now I'm going to try to focus in close on these so that I can talk about the components and you can see them up close. All right, now I am focused in on these two here now, because I need to go over terminology. This is called the hook. This is called the hook safety device. spring loaded. This is called the outer strap. That's the outer strap. This is the inner strap. This is the inner strap. The inner and the outer straps both go through the eye of the hook. This is the swallow of the hook. This is the eye of the hook. The inner and outer straps go through the eye of the hook. The entire body of the block is called the shell. Now the shell is broken down into components. The shell is broken down into what are known as the cheeks of the shell or the block, a center pin that goes all the way through the shell, through the center of the two sheaves, the pin that goes through the center of the three sheaves on this larger shell. With these are the outer components, or the cheeks of the shell. These pulleys are called sheaves. This is a two-sheave block. This is a three-sheave block. The part of the shell that the rope goes into, and you can see that this is a larger area here than down here. This is called the swallow. There's two swallows on a two-sheave block. There are three swallows on a three-sheave block. The part of the shell that is the farthest away from the hook is called the breech, where the pulleys turn inside the sheaves turn inside the shell. This is the swallows. These are the breeches. The rope does not come out of the breeches. The rope goes into and comes out of the swallows. That's why there's so much more room here than there is up here. This piece here is called the becket. The becket is what you finish tying off onto with the last run of rope between the blocks in order to tie the system together so that the two blocks will function in their intended mechanical advantage purpose. Your final rope will be tied off on the becket. The becket in the three-sheave block is in the middle. The becket on the two-sheave block is on one side. You will see why when I show you how to rig these. Now let's talk about components on the rest of these devices. We covered the detailed components of a three-sheave and a two-sheave block: hook, safety gate, swallow, eye, outer strap, inner strap, shell, cheeks, sheaves, swallow, breech, becket. On a snatch block, you have the hook, you have the swallow of the hook. In this case, there is no spring-loaded safety device in order to keep the hook from coming off of whatever you're hooking it onto. So it would need to be tied off with mousing cord. Anytime that you mouse a hook closed in the absence of a spring-loaded safety like this, and you tie this across, that's where the term mousing cord comes from, because it is used to mouse the gate of the hook shut, just like this spring-loaded device does, to keep this hook from coming off of whatever it's hooked over. Now the difference between a snatch block and these blocks here is there is a swivel device. The hook is allowed to swivel on a snatch block because a snatch block is designed basically for the purpose of changing direction. There is a sheave. There is a swallow. These are the cheeks. These are steel. These are wood. But the difference is this has a swivel housing. And that's this component right here. And I want to try to bring this up close where you can see what it looks like. This is designed to swivel. It's specifically designed that way. I can actually unscrew this piece right here, this pin, which allows this side of the device to open so that I can lay a cable over this sheave, closing the cheek of the shell back and screwing this piece back shut in order to bind these two together. Now I have a cable that would run through here on a snatch block. So those are the components of a snatch block sling. I said of a snatch block sling, of a snatch block itself. Now rigging the sling for the snatch block is another matter, and I'll show you how to do that. All right, now these are also pulleys, and they are designed for different uses based upon their shape. This is a standard Russ Anderson 4-inch diameter stainless steel ball bearing pulley. Extremely durable, extremely powerful, 10,000 pounds plus. Center pin, stainless steel sheave. These separate just like this one does, only this has a pin. This one does not. Steel carabiner hooks into here. Rope comes in, rope goes out. Change of direction, which can also be used not only for change of direction, but mechanical advantage as well. Very durable, very strong stainless steel single sheave pulley. This is a double sheave 4-inch diameter pulley. This now is a block, whereas this is a single sheave pulley. This is a block. Again, the outer parts of the shell, or the cheeks, the inner part, which allows you to have a becket here. Notice that the becket is on the center piece. When this is rigged, it's rigged in a mechanical advantage system so that the rope comes back and hooks into this on a steel carabiner. Just like this is a becket here for this type of pulley, just like this is a becket for this block, and this is a becket for this block. This is the becket for this type of a stainless steel 2-sheave, extremely high quality rope block. Center pin, sheaves, becket. You probably cannot see it across here, but in the interest of safety, I always mark a line across the center of this pin and the nut on both sides so that I can tell if this nut has ever moved about this pin. It's a safety thing that I do so that I can tell whether the nut's getting loose or not. This is a single sheave pulley, but it has a longer shell, and it's designed for certain rigging systems a little bit different than these. It's designed where you need a longer attachment point than what you have here. Otherwise, these are stainless steel. This is aluminum. This still has the 10,000 pound strength. This is a Rescue Systems Incorporated single sheave pulley, 4-inch diameter, aluminum. Very lightweight, very powerful. This is a single sheave 2-inch diameter aluminum pulley. Again, 10,000 pound braking strength. Rescue Systems Incorporated makes this pulley. Center pin, shell, the cheeks, the sheave. Again, designed to handle up to 5/8-inch diameter rope. Normally, 1/2 inch is used on this. 1/2 inch is about the largest you'd want to use, but the Swallow does allow a larger diameter rope to be used. This is a very specific type of single sheave pulley. This is called a Prusik minding pulley, and it is designed in such a fashion that when a rope comes through this pulley and changes direction, a Prusik can jam up against the cheeks of the pulley. And notice the difference on how these are set apart with the other pulleys. This pulley is specifically designed for the purpose of a rope to come into it and come out of it with a Prusik that will jam up against the cheeks of the pulley and slide as the rope comes in. The Prusik will slide down the length of the rope as long as the rope is coming in. But as soon as you let off on the tension on this, then the Prusik extends back out because it's around this rope anyway, and it grasps the rope. This type of a pulley totally eliminates one rescuer from having to stand on an emergency backup system and hold the Prusik so the haul line will come through the system. This pulley is designed to do that for you. The Prusik will jam, the rope will slide. When the rope comes back out in the opposite direction, the Prusik will have grasped the rope as it is supposed to, and you have a backup system that is automated due to the construction of the shell of the single sheave Prusik minding pulley. This is a very specific type of pulley called a Kootenai carriage. KOON-TE-NEY, Kootenai carriage. The rope, of course, this rides on top of the rope. The rope comes under. This is designed to pass large knots. Notice that it has 2 pins on it. Those pins can be removed so that the cheeks of the pulley will open and the sheave will turn. Now again, the purpose of being able to take these pins out is to allow these to open, to allow the sheave to turn. And if you wish to use this as a high-line traveling system, then the pins do not go in it. But if you wish to lock this off, or you wish to prevent these from opening, which also prevents the wheel from turning because these pins will actually go through the wheel, then you put the pins back in. That is the beauty of a Kootenai carriage, made by Petzl. This is primarily used in high-line rigging systems. It rests upon the line like this, and you can hang multiple devices off of this. This is for Tyrolean traverses, Telfer lines, and high lines primarily. So with that, you've seen 9 different devices here that essentially do the same thing, but they have some individual components that allow them to do specific things, such as a change of direction versus a multiple rigged, multiple reeve pulley system to where you have a large mechanical advantage block and tackle. And I'll show you how to rig these in part 2. But I also wanted to mention something to you. If you notice, this is a 3/4 inch manila rope. A lot of people look at a manila rope and say, my God, that was on the Mayflower. Well, perhaps they had hemp sessile ropes back then. Manila is a vegetable fiber rope. They're not used much in rescue anymore. They can be. There are better ropes to use, such as the Poly Plus. And so that being the case, this is not used much anymore. But I'm going to use this as I show you how to rig the 3/2 block and tackle, because it works very well and there's nothing wrong with it. All right, so there you have it. 9 different devices, the different components of these devices and what they're used for. So now we'll take a break and I'll pick up with part 2 now, which will be rigging mechanical advantage systems for rescue. Ladies and gentlemen, this is part 2 of series number 1 on mechanical advantage systems in rescue. I'm going to go ahead and start this part 2 as though it's a separate track, in case there are departments who will use part 2 as a beginning for the technical rigging aspect only of mechanical advantage systems, as opposed to the full track where we talk about safety and other major issues and concerns associated with mechanical advantage systems in rescue. I'm Bob Toomey, Chief of the North Carolina High-Level Extraction Rescue Team, the state's helicopter rescue team. Also an instructor with the North Carolina Association of Rescue and EMS, as well as the Office of the State Fire Marshal, North Carolina Department of Insurance, Fire and Rescue Commission. This particular segment of the series number 1 of mechanical advantage systems in rescue now will deal with how to rig various aspects of mechanical advantage using snatch block slings. I'm going to show you 2 different ways to put slings onto an object. Snatch blocks, 2 and 3 sheave blocks of various types, block and tackle systems, how to reeve them correctly with your eyes closed in the middle of the night when everything that can go wrong on a rescue has gone wrong on a rescue, and you need to know that it's rigged right by the feel of the rope and the pulleys and the blocks and so forth. We're going to cover all of that, and I'm going to show you time-honored ways of doing the things in mechanical advantage in rescue. So with that in mind, we will go ahead and begin now with mechanical advantage systems. I will be moving the camera several times, showing close-ups of the exact rigging, because I want you to see precisely how to be able to do this on this video. I want you to remember that this is not the only way to rig mechanical advantage systems, the ways that I'm going to show you, but they are time-honored and proven. And it's the way the Department of Insurance teaches it. It's the way the ERT program teaches it. And if you were being certified in an ERT program, it's the way you'd be expected to know it and do it in the field. for a certification class. The bottom line is, when you rig something, rig it right. We've already talked in part one about what happens with catastrophic failures. Anchors, chains, ropes, cables, pulleys, and so forth fail. And when they fail, it generally is catastrophic. So keeping that in mind, let's do the job right the first time and every time, so that we all go back home in one piece. At this time, we'll move into the technical aspect now of mechanical advantage systems in rescue. Okay, ladies and gentlemen, now we're going to go ahead and start. I'm going to show you how to tie what's known as a snatch block sling using a standard body cord. In this case, I'm going to use 1/2 inch diameter static kern mantle. Whenever you go to tie an anchor system that is going to be holding all of the weight that you're going to put on it, do not use a dynamic rope if at all possible. You do not want the anchor to stretch. You want the anchor to remain solid and fixed. Therefore, use a static type rope. Again, if you get into the habit of using 1/2 inch diameter rope, then everything remains relatively consistent throughout the entire rigging system. One thing to keep in mind is the finest rigging system for any rigging in rescue is only as strong as the weakest link. If you have an anchor that is the weakest link and you pull the anchor out of the ground or bend the anchor, or the anchor in some other fashion fails, that becomes the weakest link. The weakest link could be Prusik cords in a system, or the rope itself, or the quality of the pulleys or snatch blocks or whatever. There's always going to be a weak link, and you must keep your mind focused on what the weak link is relative to what you're trying to rig and how you're trying to rig it. Now, at first, I'm going to rig this at a distance like this, and then I'm going to pan up close and show you how to rig it. All right, the formula for tying a snatch block sling around any object, whether you're using it for a tripod, an A-frame, or any other object, the formula is CH, 2RT, 2LT, 2HH, 2RT, CH. Now what that stands for is clove hitch, 2 tight turns, 2 loose turns, 2 half hitches around the loose turns, 2 more tight turns, and a clove hitch. All right, so here's how that works. In a broad panoramic view, here is my clove hitch. The running end of the rope, if there's going to be enough running end of the rope, you need to marry this back around the standing part. If not, just leave it as a well-tied clove hitch in this fashion. All right. CH, 2 TT, 2 tight turns. 1, 2. Keeping your ropes all neat and together. Now, 2 loose turns that will be what I put my snatch block into. There's 1 loose turn, 2 loose turns. Now, it actually ends up being 2.5 because you want to have 2 full loops at this point right here. Now, once you get to this point right here, 2 half hitches. 2 half hitches tied around the 2 loose turns to bind them together. 1 half hitch, 2 half hitches. 2 half hitches is a clove hitch. All right, so CH, 2T, 2L. Now, 2 more tight turns. 1 and 2. Now, I have a lot of rope left over. I could either continue with round turns, or I can go ahead and tie this off and just coil the rest of the rope up. 6 of one, half a dozen of the other. But as long as you have CH, 2T, 2L, 2H, 2 half hitches, 2T, CH, you can have multiple turns. I'm just going to go ahead and put 3 in, but 2 is all that's required. And now I'm going to go ahead and tie this off with my half hitches. There's 1 half hitch. And this is so simple it's difficult. Throw a second half hitch in. 2 half hitches makes a clove hitch. All right. CH, 2T, 2L, 2H, 2T, CH. Now the rest of this rope can just be coiled up and set out of the way. Or you can just leave it laying down at the base. This is right here is now what I hooked my snatch block into. This now is a snatch block sling. Now let me focus in close on it, and then I'm going to focus in close on it as I tie it so you can see how it's done. All right, here's the sequence. Snatch block sling, clove hitch, 2 tight turns, 2 loose turns, 2 half hitches around the loose turns, 2 more tight turns, clove hitch. CH, 2T, 2L, 2H, 2T, CH. That is how you tie a snatch block sling. Now let's tie this again from the beginning so you can see how it's done. See, there's the clove hitch. There's my 2 tight turns and my clove hitch. All right, let's do it. Clove hitch. This is what you would use at the bottom of an A-frame on one of your poles. All right, clove hitch, 1 tight turn, 2 tight turns. Now, 2 loose turns. All right, now at this point right here, watch what I do. All I'm going to do is throw two half hitches into the system. And it doesn't matter which direction you put your half hitches in, a half hitch is a half hitch. There's 1 half hitch. There's the second half hitch. There's the clove hitch. 2 more tight turns is a minimum. 1, 2. Now, in case you cannot come over the top like I just did right here, all you do is you just tie your half hitches. Okay, 1 half hitch. 2 half hitches. 2 half hitches is a clove hitch. There's your clove hitch. The rest of the rope coiled up and laid out of the way. All right, here you have it. Clove hitch, 2T, 2L, 2H, 2T, CH. Snatch block sling. Snatch block goes into the sling in this fashion. Always put the snatch block sling in such a fashion that the point of the hook faces downward and the swallow of the hook is around the rope in such a fashion that if slack should come upon this snatch block device, that it tends to hang into the system as opposed to being put in upside down like this, where if the hook is not moused shut to prevent it from sliding off, that it won't do that. Okay. All right, now I'm going to show you an alternate way to tie a sling using 2-inch tubular webbing. The first way to tie a snatch block sling that I showed you was using 1/2-inch static kern mantle rope in a configuration known as a snatch block sling, tied from scratch. All right, this is a piece of 2-inch tubular webbing, 10 feet long. Now, while I'm thinking about it, let me just give you the definition for how to determine the finished length of a cut piece of tubular webbing. If this webbing is 10 feet long, what will be the finished length of this webbing? The way you determine that is 10 divided by 2 minus 1. 10 divided by 2 is 5, minus 1 is 4. This is approximately a 4-foot long piece of tied tubular webbing sling now. You divide the total length by 2 because it's going to be cut in half, because it's no longer a straight piece, it's doubled. And you take at least a foot off for the water knot in the webbing that you can see here in the top right directly in front of me. So the definition for any piece of webbing, if you want a 12-foot long sling finished, tied off like this, and you want it 12 feet long, then that would be 2 times 12 plus 1. 2 times 12 is 24 plus 1 is 25. So you would need a 25-foot piece of tubular webbing doubled, which is divided by 2, minus 1 for the water knot, in order to end up with a 12-foot long finished product. That's just a little side benefit that I'll throw in right now on how you calculate the length of a sling. All right, now, if I wish for this sling to point in that direction, what a lot of people will do, and this is terribly incorrect, and you should never do this. A lot of people will just take the finished sling like this and lay it over the object and bring it together like this in order to hook their snatch block or carabiner or whatever into. But now, the inherent problem with this is this allows the sling to do this number, and it wears upon itself. Now, that could be desirable if you want a self-adjusting sling in such a fashion that it can move around. Bear in mind very, very carefully that a piece of webbing doing this under great load around a tree or around any object, even this smooth metal pipe, will generate great friction if it's under a heavy load, and it will cause excessive heat and possibly premature failure of this sling. If you need an adjusting sling like this, I would recommend that you tie a self-adjusting load distributing anchor system as opposed to a sling that will move back and forth like this. I do not recommend that this be tied this way, but you'll see it done. But it has inherent risks, and you must be very careful. And therefore, I will not teach this to be tied in this fashion. If I want the bites of this sling to come directly towards me, keeping the knot out of the way because you never want to load the knot, I actually will start in the opposite direction and bring the two ends around each other, around the object, in such a fashion that now I have the two bites of this loop facing in the direction that I want, with the knot not being around the object and the knot not being where I'm going to hook into the sling, but the knot somewhere between this point and this point where the knot is not loaded directly. You don't want the knot behind like this, and you don't want the knot way up front like in this fashion to be loaded. You want the knot somewhat out of the way like this. All right, put the two slings, the two bites of the sling together, and hook your carabiner or your device into the sling in this fashion. Now the benefit to this is the tighter this pulls in this direction, then the more this sling seizes around the object about which it's tied. It is not designed to move back and forth in this fashion, and under great load it probably will not, because the more you pull on this, the tighter it will bind around the object. But now the thing to keep in mind is if it does do this number under great load, friction and heat are the two most dangerous, devastating things associated with nylon slings that can cause them to fail catastrophically, as well as sharp edges or anything that could tend to puncture the webbing or put undue pressure at any single point throughout this wrap, this round turn wrap around the anchor, that would cause excessive loading at any individual spot in the sling itself. All right, so now I'll focus up a little closer on it. This is the way it's tied. Take your sling, keeping the knot out of the way. I want the loops to come toward me. Of course, this wall's in the way, or you can, I have to make adjustments for that wall being in the way. All right, now. All right, there is my two loops. Here is the knot, well out of the way. It's not being loaded on the anchor, and it's not going to be loaded where I hooked a carabiner or snatch block sling into. All right, now, just put one sling right around the other sling, just like this, or loop rather. Put the snatch block into the two loops, and now you can see there is my system. Okay, that's how you rig it. Again, with the point of the hook facing down. Okay, that's an alternate form for tying a snatch block sling around an object. Okay, ladies and gentlemen, if you'll remember now, I told you that one of the things we wanted to talk about was how to use mousing cord, which is this very powerful nylon waxed string that was given to Bard Rescue by an agency in the county. This is what you use, something this fine and this powerful is what you use to mouse a hook shut if it does not have an automatic spring-loaded safety mouse or safety gate on it like this. All right, this two-sheave block has a safety gate. This snatch block sling does not. Therefore, in order to tie the exact same thing, here is the process. Take about an 18-inch length piece of this waxed cord, very strong cord, and form a girth hitch at the base of the hook. One of the few times that a girth hitch is used in rescue. Now, at this point here, I've got two ends. I will split the two ends, and I will wrap these ends in opposite directions, going from the base of the hook, always from the base of the hook to the tip of the hook, and I will wrap these at least twice around, if not more than twice, depending upon the size of the hook and the length of the cord. But that's why the cord should be at least 18 inches long. Now, at this point right here, pulling these very tightly in order to create this gate, I am not finished yet. Now, what I do at this point in time is I go ahead and finish this wrap around the tip of the hook, and then I go into the swallow of the hook itself. And then I begin to bind these pieces together tightly, very tightly, as tight as I can get them, because this can always just be cut with a knife when you're finished with it. Wrapping again in opposite directions, pulling these pieces together, and finally, when I have just enough left to tie this off, I tie it off with the usual knot, right over left, left over right, which is a square knot. Left over right, right over left. Now, I have a little bit of extra rope left over, or a string in this case. If I want to keep it very neat and everything out of the way, I can trim those ends a little bit out of the way, as I have done right there. Now, this right here is my safety. And if this is put on tightly enough, whatever this is hooked around, this now becomes the safety gate. And the reason that it has to be tied tightly is so that it will not slide off. All right, I'm going to pull on this. And I've got a moderate amount of tension on that, and it did not pull off the tip of the hook. So now I'm going to focus up on that very closely so you can see how that was done. Okay, you can very, very plainly see now that I started with a girth hitch, split the two ends, wrapping in opposite directions from the base of the hook to the tip of the hook, wrapping in opposite directions at least twice, and then splitting the ends again after coming around the tip of the hook, or I could split the ends again after coming around the base of the hook. It depends again on how much string is left over. And then I bind these wraps together tightly again so as to form a safety hook. Now, in the same fashion, I have formed the same thing on this snatch block sling that this block has in a mechanical safety I have tied with a piece of string. Always get into the habit of mousing the gates of your hooks. This is called the gate of the hook. The tip, the base, the swallow. Mouse the hooks closed at the gate. That will keep this from, when load comes off of this, that will keep this from coming off of the rope or the sling or whatever you have this around, because now it's safetied off. When you get done, this has been tied so tightly that when you get done with the object, the rescue or whatever, simply take your rescue knife that every rescuer should have and merely cut the string Totally remove it from the hook. And now your hook is free and clear now to be taken off the sling.